Hi, my name is Ahmed Sikafi. In this short presentation, I will walk you through the key findings from a literature review on the behavior of foundation piles in offshore environments. As objective, we have that the main goal of this review is to understand how foundations piles behave in marine settings by looking at their load capacity, the effects of insulation, and how they interact with the soil surrounding. To give you some context, offshore platforms like wind turbines or oil rigs are often built in environments with weak surface soils. To stay stable, they rely on deep foundation piles that transfer load to a stronger layers below. These piles face not only vertical pressure but also lateral forces from waves, wind, and current. So understanding their behavior is key to safe and sustainable design. The first article that we reviewed was the behavior of monopole foundation for offshore wind farm in sands. The authors are Liu, Su, Ling, Liang, and Ling. The objective was to analyze the behavior of large diameter monopiles in sandy soils. The method they used were physical testing and computational simulations. Some findings, they found out that traditional design method underestimate the load resistance. Conclusions that we can take from this article is that soil arcing and confinement effects must be considered for more accurate models, and the relevance was that the key for safer offshore wind turbine foundations. The second article that we studied was the one of the by Zhu and Zhang in 2011, focused on the open-ended steel piles in sand using the CPT data or clone penetration test to estimate basic capacity. They show that when sand fills the insides of a pile, it boosts actual resistance significantly. Their model includes the plug effects of um, the pile length to diameter ratio, making it more accurate than older approaches. This is especially useful in granular soils, helping engineers improve safety and reduce the over-design. The third study was by Kovacevic and others in 2008, investigate how nearby drilling affects foundation piles in clay. They used the land simulation and field data to show that drilling near a pile can increase pore water pressure and cause the soil to shift, reducing the pile's load bearing capacity. This highlights a crucial factor, how construction method can unintentionally weaken the foundation. Here are some key takeaways and application. Together, this study show us that pile-soil interaction is complex and needs to be analyzed with real condition in mind. CPT data and plug effects help us improve actual design, and construction impacts like drilling must be included in early planning. These insights are directly useful for building safer offshore infrastructure like ports, wind farms, and oil platforms. To conclude, this literature review shows that behavior of foundation piles is deeply influenced by soil condition, installation method, and environmental forces. By using improved model site-specific data and accounting for construction impacts, we can design offshore structures that are safer, more efficient, and better adapted to their environment. And finally, here are my reference used for this review. Thank you for watching.